sensors and getting values. When I mean sensors, this course is mainly situated around the color sensor and the various forms and how we can use the color sensor. So let's take a look about how a color sensor works. So the color sensor or the light sensor sends an object at the light. However, only a small percentage of the light is reflected, and the percentage is what you see. And the reflected light goes inside your eye, and that's how you see it. And in the case of a color sensor, the color sensor has an emitter and a receiver where it reads the color percentage value. So that's basically how a color sensor works. But now, how do we code with a color sensor? So the color sensor can be found in the yellow sensor section, and the color sensor has three modes: color, reflected light intensity, and ambient light intensity. We won't be needing ambient light intensity. We personally have never used it. My team and I have never personally used ambient light intensity, but it's still cool in case you want to use it for other non-FLL things. So most of the time, like I said, you'll use for color or reflected light intensity. And we can use the color sensor to find specific colors like gray, blue, red colors. And we can use reflected light intensity to get a percentage of reflected light back. Meaning that we can shine a light on an object and we can sense how much of the light is getting reflected back. But to understand these concepts further, let's watch a few videos on reflected light intensity and the color modes of the color sensor. To the color sensor. The color sensor can be found in the yellow tab, the sensor tab, and it is the second to the right, from the left to the right. So let's drag out the color sensor block. So when you drag out the color sensor block, it has three different modes: measure, compare, calibrate. And inside each one of those, except calibrate, it has three more modes: color, reflected light, and ambient light intensity. You'll mostly be using, actually, we only use measure and color and reflected light intensity. And yeah, so now what is a color sensor? So let's review. First, a color sensor is a sensor that outputs a color and reads in a color back, and it gets a value. So let's look at some of these values. So a color sensor has different modes. It has the color, reflected light intensity, and ambient. Like I said before, we'll only be using color and reflected light intensity, but for this introduction, we'll be using color. So there are different colors. I can't show it to you with this color sensor block because we don't know what colors are. It doesn't approximate the colors. But if we drag out this weight block like in our previous video, remember all these parameters. We go to the color sensor, we go to the compare, we go to the color, and this is the color sensor port. Remember, our numeric ports are our sensor ports. So we have all these different colors: 0, which is no color, all the way from black to brown, and that's 1 through 7. So we have all these different colors. The default's to 5, so you need to unselect color and reselect color. So that's basically the idea of how the color function works. So we have all these different modes, and we can use the color sensor to read these values. We can also use the color sensor to find certain values on the FLL mat itself. So let's look at this FLL mat. As you can see, this FLL mat has these different black and white lines, with the black line being in between two white lines. So you can see that we can use a color sensor to distinguish a black color, right? And that's kind of how we can use the color sensor. And let me show you how to do that. Alright, so now let's look at this color, this line finding code. So we're going to use our move block so we can find the line. So our robot will go on. 50 speed is generally really fast. We would like scaling it down to 30. 30 is a nice starting off speed. I just prefer it. So our robot will go on for 30 seconds. Just remember the wait block until the color sensor senses a value of black. Then we'll need our motors to turn off. And here we have a line finding code. So basically, our robot will move on until it senses one of these black lines with a sensor in port 3. And we can use this to find a line. So let's suppose that you just did a bunch of, your robot just did a lot of movement, but you don't know exactly where your robot is and how far it is to get to another location. So what you can do is you can use this line finding code to go to a line in that direction, and then you should have some sense of location with your robot. And that's basically how to use the color sensor in the color mode. Alright, so now we're going to watch a video of our line following code to find this black line. Let's run it. As you can see here, our light sensor has stopped completely or a little bit over the black line, and the robot now has a sense of location relative to the starting position, assuming your robot starts in a position that's unknown. And that's how the line finding code works. And notice how the robot's not aligned. This code will only allow you to find an average location. Now let's take a look at the other modes of the color sensor. When I mean other modes, I mean reflected light intensity. So remember, sensor section, the second from the left, and we have our color sensor. Here we have measure color, and let's go to reflected light intensity. But first, let's talk about reflected light intensity. Reflected light intensity is how much light is reflected back from the color sensor. So, as I said before in the previous color sensor video, the color sensor sends out a light, and then it reads the percentage of the light value it gets back of that light. So, let's explain. So, a percentage is from 0 to 100. Straightforward. That's basically how a percentage works. 0% to 100% being all of the lights getting reflected back. And using our knowledge of colors and how light gets reflected, we know that a dark color does not reflect a lot of light, and a light color reflects a lot of light. And to put this into perspective, I'll say that black equals 0% reflected light, and white equals 100% of white. 100% of the light reflected back. So we can use this value to, like I said before, align to these lines on the mat. So there's another interesting thing that I'd like to show you about. It's called multi-threading. So let's suppose we have two actions going on at once. Okay, let's suppose we want our medium motor to go on while let's suppose that we want our medium motor to go on while we are moving. So there's two ways we can do this. We can drag out another start block if it's happening at the beginning, and we can do motor goes on, and then this motor goes on if it's at the beginning. However, if it's not at the beginning, there's another way to do it. You can just add a wait block, but then that gets really time consuming every single time you want to put two blocks at once. Or there's another thing. It's called multi-threading or parallel beam synchronization. Parallel beam synchronization or multi-threading, I like calling it multi-threading for short, is basically the idea of running two things at once after the same start. Okay, so let's suppose we wanted to, let's say, have our same thing, our port D, or let's say B, because it's our motor, go on for rotation, and we want our medium motor to do on for rotation also. Suppose we want to do that both at the same time. And let's suppose that there was some other code before it. Let's suppose, yay, there was some other code, yeah. And then let's just suppose, yeah. Let's suppose there's some other code, and we don't know the exact time. What we can do is there's this thing called parallel beam synchronization. What we can do is we can drag this out from right here, and we can multi-thread it and have both of these go on at the exact same time, which is immediately after this. So the context is this will happen after this, directly. Both will go simultaneously, irrespective of each other. And we can use this kind of idea to create a very interesting code called a line squaring code. So in line squaring code, we use the color sensor to find a specific reflected light intensity of a line, and if one motor stops, then the other will continue going on until it finds that value. So let's take a look at line squaring even deeper. At its core, one light sensor controls one side of the robot. So after watching those two videos, you saw how we have line finding and line squaring. But which one is better? Let's take a more in-depth look about line finding and line squaring. So first we have line finding. Line finding can find the line, and it gives a relative sense of location. It's not aligned to the line, but we know it has a sense of location. And line finding only uses one light sensor. On the other hand, line squaring, finds and aligns to the line, meaning it aligns perpendicular to the line. And line squaring gives a complete sense of location because you're perpendicular to the line and you know where the line is. So you know you're perpendicular to the line and your light sensors are on the line. So you know complete exact location. However, line squaring requires two light sensors, and if you don't have two light sensors, you cannot perform line squaring because a line requires 2 points and each sensor acts as a point. But now let's look at how both work. So in line finding, the color sensor will go on until the robot finds a line. However, the robot is not aligned to the line because, like I said before, the line needs 2 points to be classified as a line. So this is why we use two color sensors over here. One light sensor will stop on the line, the other one will keep on going, so this light sensor will tell this side of the motor to stop. This light sensor will tell this motor to keep on going on. That way, we keep on going on until we're perpendicular to the line. And one light sensor is just not enough information to align. You need 2 points to create a line, like I said before, and that's very important. So yeah,